Hello. In this video, we're going to go ahead and look at the following. We want to find the following limit of the limit as x approaches 0 of the absolute value of x divided by x. Now, notice that we're approaching 0, so if we plug in 0 in the numerator and denominator, we get 0 over 0, and that, again, tells me that something weird might be going on. It doesn't guarantee that we're going to get a limit, but it says that we might. Okay, so let's look and see what's happening here. To do that, we want to say we're going to go ahead and look at a table here. So doing this with the table, values to the left of 0 would be negative 0.1, then negative 0.01, and then negative 0.001. Numbers to the right of 0 would be 0.1, 0.01, and 0.001. And that's close enough, so let's go ahead and go to the calculator to figure out what these values are going to be, and also kind of look at what the graph is going to look like here. Alright, I'll see you there. Okay, welcome to the calculator. Let's go ahead and type this function in the calculator. Go to y equals alpha y equals enter. That gives us the fraction over fraction. So to do this, we need to type in absolute value of x. To do that, we need to go to math and go right to num and see where it says ABS, click enter. Notice that it gives us the absolute value symbol. And then just put x in the middle. Use right arrow, and then right arrow again to go to the denominator. And then in the denominator, click x. Awesome. So this is the function that we want to take the limit as x approaches 0 of. And just kind of see what's happening here. Let's go ahead and go to the standard window, zoom 6, and here you go. Notice that it's negative 1 this entire way from when x is less than 0, and it's 1 when it's greater than 0. But it's still undefined at x equals 0. Neither of these will be 0 for either one. Or neither of these two will be have a closed circle. Okay. So let's go to vars right1 enter just to see that this works. So negative 0.1 should give us negative 1. It does. Awesome. So negative 1, good. Do this again. Negative 0.01 give us, well, negative 1. Because everything to the left of 0 should be negative 1. And again, that gives us, again, negative 1. Good. Now, notice something, that if we do vars right1 enter, and then open parentheses, tell it to do it of the number 0, it gives us the fact that we're dividing by 0. We don't want that. Alrighty, so 0.1 is the next number we want to look at, which is 1, because we're to the right of 0 at this time. And then if we do 0.01, it should give us 1 again. It does. And then do this one more time. That gives us 1 again. So basically what's happening here is what the graph looks like. When you're to the left of 0, the y value is negative 1 the entire way. When you're to the right of 0, the y value is positive 1. And the reason that this is happening is because we have absolute value of x divided by x. In other words, the magnitude of x divided by x. So we're actually always going to get either 1 or negative 1. It just depends on if x is positive or negative. Notice if x is in the negative realm, the absolute value of a negative is always positive, so the numerator is always positive no matter what. But we have a positive over a negative giving us a negative. That's the reason why over here, when you're to the left of 0, when you're negative for your x's, you're going to get negative 1. If x is positive, you have a positive over a positive gives us a positive, which is why to the right of 0, aka positive, we have it at 1. And again, you can see all this by going to the table. There you go. And there's your error. Alrighty. I'm going to go ahead and see back in the notes, and we will finish up this example. Okay, welcome back to the notes. Notice that as x goes to 0, from the left-hand side, we get negative 1. And as x goes to 0 from the right-hand side, we're getting 1. So what this is telling me is that the limit as x approaches 0 from the left-hand side of this function is -1, and the limit as x approaches 0 from the right-hand side of this function is +1. But notice that that's telling me that the limit from the left-hand side is not the same thing as the limit from the right-hand side. And that's telling me that the function value does not exist, or sorry, the limit here does not exist. Therefore, the limit as x approaches 0 of the absolute value of x over x does not exist. And there you go. Alrighty. Well, I believe that's it for this video. I'm going to go ahead and end it here, and I will see you in the next one. Have fun.